have some fun with Dmitry Mendeleev. Hello, Mr. Mendeleev. How are you?
I am fluorine iodine neon.
What?
I said I'm fine. Get it?
Oh, that's pretty funny. Okay, so tell us about your awesome life.
Well, I was looking forward to organizing all the elements by their density, appearance, atomic mass, melting point, and compounds formed, and I eventually ordered them by atomic mass. So as you see, the periodic table that I made by myself, you see the atomic mass increasing.
Interesting.
Wait! Did you just say you made that table by yourself, sir?
Hello? Who are you?
Hi, my name is Henry Mosley, and technically I finished the table. Also, I figured out that atomic numbers are known as the number of protons.
How dare you, Henry? I finished the table. See?
And what are all these question marks?
Okay, calm down. I knew the elements would exist, but I couldn't figure it out.
And who filled in those gaps mostly?
Oxygen, magnesium. I can't even. This interview is over.
What? What's that mean?
OMG.
This is periodic table. Periodic table is organized by atomic number, which is number of protons. In periodic table, there's metals, nonmetals, metalloids. Metals are located right here, and they have few valence electrons. They're solid at room temperature, but mercury is liquid at room temperature. They have good conductor, shiny, and malleable, and ductile. So copper is used in electric current. Nonmetal is located right here. They have complete set of valence electrons, and they're gas at room temperature. They're poor conductor, not shiny, and not malleable, and not ductile. These are metalloid, and metalloid has half complete set of valence electrons, and they're semiconductor, shiny, and not malleable. So the vertical line represent the groups, and then the horizontal line represent the periods. The groups is determined by having a similar chemical and physical properties. So the first group is alkali metal. You can't see, but they're supposed to be a first group. They're most reactive metals because they can easily give away one electrons. They have one valence electrons. They're soft, silver colored, shiny, and low density. The second group is alkali metals. Alkali ars metal. They're most reactive metals, and they have two valence electrons. They're silver colored and more dense than group 1. The third group is transition metals. They have one or two valence electrons, and they have higher densities and melting points. And this group is boron group. They have one metalloid and four metals, and they have three valence electrons, and they're solid at room temperature. This group is carbon group. They have one nonmetal, two metalloids, and two metals. They have four valence electrons, and they're solid at room temperature. This group is nitrogen group. They're nonmetals, two metalloids, one metal, and they have five valence electrons. And they're solid at room temperature except N2's nitrogen is a gas. This group is oxygen group. They have three nonmetals, one metalloid, one metal, and they have six valence electrons. They're also solid at room temperature except oxygen, because oxygen is a gas at room temperature. This group is halogen, and they're nonmetals. They have seven valence electrons. They're very reactive with alkali metals to form salts, but they're never found uncombined in nature. The last group is noble gas, but you can't see. They're non-metals. They have 8 electrons, but helium has 2 valence electrons. They're unreactive because they have full valence electrons, and they're colorless and gases at room temperature. And when you look around the neon lights, they're made of noble gases. And I forgot one group. It's hydrogen. It's supposed to be here, but I'm sorry, you can't see. They have 1 valence electron, and they're really, really reactive. And they are gas at room temperature, and they have low density. And then the last group is lanthanide series and actinide series. The reason why they call lanthanide series is because they follow the lanthanum. In actinide series, they follow actinium. That's why they call lanthanide series and actinide series. These are S blocks, these are P blocks, and these are D blocks, and these are F blocks. This is atomic radii. As you go down, it increases because you're adding energy level. As you go right, it decreases because you're not adding energy level and you're adding protons, which makes them to get smaller. This is electroaffinity. Electroaffinity is attraction of an atom for additional electrons. As it goes down, it's almost same. As it goes right, it's increasing because there's more number of electrons released, and it's also approaching more stable. This is electronegativity. Electronegativity is the ability for an atom to attract electrons from a neighboring atom. So as you go down, it decreases. As you go right, it increases, and the fluorine has the highest electronegativity. This is ionic radii. As it goes down, it increases, and as it goes right, it decreases, and from some point it increases. And ionic radii has cation, which is positive ion, and anion, which is negative ion. As cation charge goes that way, the size of atom goes the opposite way because it's taking away electrons. And when anion goes that way, the size of atom goes the same direction because the electron cloud spreads out. This is ionization energy. Ionization energy is a removal of electrons. As it goes down, it's decreasing because it's adding energy levels, and it's farther from nucleus. As it goes right, it increases because it's adding protons, and it's tighter. This is valence electrons. Valence electrons is outermost energy level. As you go down, they have the same valence electrons. As you go right, it increased by 1.